Hello, ladies and gentlemen, and welcome back to Prospect Charter School's Algebra 1 course. Today, we are going over section 6.2, Solving Systems of Equations, using the submethod. So, the submethod actually is short for the substitution method, and it's kind of like a substitute teacher. They go in, they replace their teacher for a little while, and then they go away. Well, it's the same thing here. We are going to use substitution of one variable for another to figure out where a system of equations intersects another equation. So, let's begin with a simple example. Let's start out with the system of equations denoted by y is equal to 2x, and the other equation is going to be y is equal to x plus 5. Now, in doing the system of equations, it's a series of tasks, I guess is the word that we can use. It's a series of things that you do in order and repetitively, and it gets boring sometimes, but it's something that we need to get down. This kind of thing is called an algorithm. And an algorithm is a set of instructions. A set of instructions. Now, if you follow the algorithm, you will get it right every time, guaranteed, as long as you don't make any silly mistakes like 2 plus 2 being 5, or 12 minus 1 is 21, or something ridiculous like that. So just remember, an algorithm is a set of instructions. Now, for this algorithm, what we are going to do is we are going to substitute one equation's number, or one equation's variable, for another. So for an example, on this one, I notice that my y's are already solved for. They're on one side of the equation with everything else on the other. So what I would do is I would substitute 2x for y in the second equation. Now, what does that look like? Well, what I'm going to do is I see that y is equal to 2x, which means that this y down here should be the same thing as this y right here. Now, writing it out linearly, like all in one line, I would see that 2x is equal to y. But y is also equal to x plus 5. Now, we should remember from before, if a is equal to b, and b is equal to c, then a is equal to c, because you have a equal to b equal to c. We just take out the middleman and we get to the ends. We're going to do the same thing here. Our middleman is this y value right now. So we're going to eliminate the middleman, and we are going to say that 2x is equal to x plus 5. Now I solve for x. Now, when I'm solving for x, I want to get x on one side of the equation and everything else on the other. So I subtract 1x from both sides, and I get x is equal to 5. And now I have x on one side and everything else on the other, so I am done. I know that x is equal to 5, which means that for my ordered pair, I have 5 comma something? Nuts, we're not done yet. Yeah, we've been able to find out what our value of x is, but we also need to find out the value of y, because all systems of equations are answered with a ordered set. Alright, so my x is 5. Great. Now, how do I find my y? Well, looking back up here, I know that y is equal to 2x. Well, if x is equal to 5, what would the y have to be? Well, I plug it in. So I have y is equal to 2x, where x is equal to 5. That means that I have y is equal to 2 times 5. And we all know what 2 times 5 is. That's right, 10. So we plug in 10 to our separate part, and we have our solution to the system of equations. So the submethod is a method of substituting in one equation's value for a variable into the other and then solving for that variable. And then we have to go backwards. So it's really complicated, but after you see it and do it a million times, it becomes a lot easier. It becomes rote memory, kind of like throwing a baseball. If you think about it, throwing a baseball is actually kind of complicated, but the more you do it, the easier it becomes. So let's look at a separate example, one that's a little more complicated, so that we can see the steps one at a time. All right, let's say that we have 2x plus y is equal to 5, and we have y is equal to x minus 4. So what we would do in this particular case is find one variable that's solved for another. I think we found it. Y is the same thing as x minus 4, which means that I can take this y value and plug it into the y value in the previous equation. So that would look something like this. I would have 2x plus y is equal to 5. But I know that my y is really x minus 4. So I would plug in x minus 4 for that y value. So then I would have 2x plus y, which is really x minus 4 in disguise, and that's equal to 5. I then perform my normal operations to try to isolate the x. So I would have 2x plus x minus 4 is equal to 5. Combining like terms, we have 3x minus 4 is equal to 5. Add 4 to both sides, we have 3x is equal to 9. Divide both sides by 3, we have x is equal to 3. Now we might be tempted to say, yes, I found x, I'm done. But no, we have to find y as well. We need both coordinates, the x value and the y value, for a system of equations. So I'm going to take this x of x is equal to 3, and I'm going to plug it back into my other equation. So right now my equation is y is equal to x minus 4, but my x is supposed to be equal to 3. So I plug in 3 for x, and I have y is equal to 3 minus 4, which of course is y is equal to negative 1. So when I'm doing these, one of the rules of thumbs that you should always do is always plug in your number for the variable. And when you do so, always plug it in into parentheses. See the parentheses. See the parentheses. Let's look at the previous one. See the parentheses. On that one, I didn't really do any substitution. I just kind of set them all equal to each other on the line. But if you'll note, every single time I did any kind of a substitution, I always plugged it into parentheses. There is a reason for that. Get used to doing that. It will make your life infinitely easier when we get to more complicated situations. Always plug it into parentheses. No exceptions ever. Okay. Now let's look at one that isn't so simple. Let's look at x plus 4y is equal to 6, and x plus y is equal to 3. Now in this system of equations, we'll note that neither one of them has a single variable on one side and everything else on the other. So for this one, we're going to have to solve one equation for a single variable. That will always be my step 1. Let's write this one out. Step 1. Solve one equation for one variable. Now in the previous ones, it's already been done for you. This one, not so much. So on this one, because I don't like dealing with 4, I'm going to avoid it and say that it must be plague-ridden, and I'm going to go ahead and solve my second equation for one of my two variables. And I think I'm going to solve for x because I want to eliminate my x. All right, so let's go ahead and eliminate our x here. To do that, I would take x plus y is equal to 3, and then I would subtract y from both sides. And I'd have x is equal to 3 minus y. I then take this and I plug it back into my original equation, or my first equation. My first equation is x plus 4y is equal to 6, so I'm going to go ahead and plug that in. So I have, let's see, x plus 4y is equal to 6, and I plug in this 3 minus y for the x. So then I would have 3 minus y plus 4y is equal to 6. This was, of course, step 2. Step 2 is sub the solved variable into the other equation. And that's what we did right here. We solved for x, bam, we got it. And now we have just subbed it in to the other equation. After I've solved or subbed it in, I do step 3. Solve for that variable. So it looks like that we're going to have to solve for y here because that's the only variable left. All right, so we're going to be left with 3 minus y plus 4y is equal to 6. Combining like terms, we get 3 plus 3y is equal to 6. Subtracting 3 from both sides, we have 3y is equal to 3. Dividing both sides by 3, we get y is equal to 1. We now have one of the variables solved for, which means that we got to go on to our next step. Step 4. Sub the value into one of the original equations. So in this particular case, we've got 1. Now we got to scroll up to find our original equations. Our original equations are x plus 4y is equal to 6 and x plus y is equal to 3. Since I've already used the green equation of x plus y is equal to 3, I'm going to go with red this time. I'm going to sub 1 in for y for x plus 4y is equal to 6. So let's go ahead and do that. We have x plus 4y is equal to 6. Our y value is 1, so we plug that 1 in for our y. When we do that, we have x plus 4 times our y value of 1 is equal to 6. And of course, this leads us to our final part. Solve, step 5, solve for the remaining variable. Now I know this is going to be a longer video than normal, but please bear with me. I will try to get through it as quickly as possible. Okay, so we have x plus 4 times 1 is equal to 6. We have x plus 4 is equal to 6. We have x is equal to 2. I now have my x value and my y value, so I put them together and I get the coordinate point of 2, 1. So the solution to this set of equations is at 2, 1. So what is our algorithm? Well, it's a 5-step algorithm. Step 1. Step 1, solve one equation for one variable. Step 2, sub the solved variable into the other one. Step 3, solve for that variable. Step 4, sub the value into one of the original equations. And step 5, solve for the remaining variable. It is kind of complicated. It does take up some space, but it's something that we can get used to doing. If you need to, write down those 5 steps and use it as a cheat sheet, and you go through it every time. Step 1, 2, 3, 4, 5. Do it over and over and over again until you get it down. And we are going to go over one last problem, and then we're going to call it a day, and you can start working on your homework and practice. So here it is. Our last one, which is going to be kind of hard, is 4y plus 5x, minus 5x is equal to 9, and x minus 4y is equal to 11. Now, when we're looking at this one, we're like, Mr. O'Neill, there's nothing solved for already. And I say, yes, you are correct. There is nothing solved for. So we got to figure out which one we want to solve for. For me, a good rule of thumb, I'm going to write it over here. Rule of thumb is look for the easiest one. Look for the easiest one to solve for. If you have a number in front of your variable, like a 4 or a 5 or a -5 or something like that, it's going to be hard. But if you see a 1 in front of it, it's super easy. Looking at these, are there any 1s in front of a variable? I think so. I do believe we found one. So I'm going to solve for that x. So I'm going to rewrite it. X minus 4y is equal to 11. Solving for x, I get x is equal to 4y plus 11. I then go on to my next step, which is to sub this in to my other equation. So I have 4y minus 5x is equal to 9, but my x value is really 4y plus 11. So I plug that into my x variable, which is right here, which gives me 4y minus 5x, which is 4y plus 11, is equal to 9. And this is where we get some trouble. Here we have to use something called the distributive property. It's actually a law, so I'm going to call it a law. Distributive law. Now, the distributive law is where we take our number and we distribute it to all of the pieces. So when I distribute it to all the pieces, I have 4y minus, -5 times 4 is -20. -5 times 11 is -55. And at this point, you'd probably be panicking, be going, oh my God, Mr. O'Neill, the numbers are too big. I have to tell you, don't worry. It'll be easy. So let's combine our like terms. We have a 4y and we have a -20y. That gives me -16y. And then I can add 55 to both sides. So 55 plus 9 would give me 64. So I put a 64 over here. Divide both sides by -16. So we have y is equal to 64 over -16. And this is where our bullpens come into play, because we've been working with numbers like this for quite some time now. I know that 64 and 16 are both divisible by 8, so I divide them both by 8. 64 divided by 8 is 8. 16 divided by 8 is 2. Hey, look at that. They're both even. So I divide both of them by 2, and I get -4. So I have y is equal to -4. Whew. What about x? Well, we already know what x is. X is equal to 4y plus 11. We can see that from the substitution right here. So if y is -4, we just plug it in. We have x is equal to 4 times our y value. What color is that? Green? Okay, green. Of -4 plus 11. So 4 times -4, It's negative 16. So we have x is equal to negative 16 plus 11. X is equal to negative 5. Which gives us our final coordinate points for our solution at negative 5, comma, negative 4. That one is as complicated as I'm going to throw at you, other than the ones with, fractions, because you gotta love fractions. All right, so before you go work, or bug work, because this really is a little bit complicated, I'm not going to give you too much. Let's go section 6.2, hashtags, gotta love the fractions, 1 through 7 odd. And then I'm going to give you so much more. 11, 15, 17, and of course I've got to give you fractions, right? After all that love, yeah, that's right, got to give you fractions. And who doesn't like money? So 25. All right, all done. Good luck and have fun.